Welcome to qnawire.
In this problem, we have centripetal motion, and we can use what we know about it to find the normal force at point A. Now first, let's begin talking about point B to extract any information that can help us for point A. Point B, we have the car in this free body diagram. And we know that gravity, of course, is pulling it downwards. But also, the track is exerting a normal force on it. So we have normal force and force of gravity. And since it is accelerating with a centripetal acceleration, then we know that the centripetal force is made up by these two forces. So centripetal force at point B is equal to the normal force at point B plus force of gravity, which is the mass of the car times gravity. And we were given the normal force at that point. We're told that it is 6 newtons. We know the mass of the car, 0.8 kilograms, and we know gravity. So that helps us find the centripetal force. But why do we need it? Well, if we draw a similar body diagram for point A, we get that the normal force is pointing outwards in this case, so towards the center of the loop, whereas gravity remains pulling the car downwards. But the centripetal force has to remain the same. So that means that these forces have changed so that they add up to the same centripetal force. Therefore, at point B, we can get that centripetal force and take it down to point A and say that the centripetal force at point A is equal to the normal force minus the force of gravity. So the normal force point A is equal to the centripetal force plus the force of gravity. So let's use a calculator to find the centripetal force. And that gives us 13.84 newtons. Now let's get rid of these subscripts because we just said that the centripetal force has to be the same. So now we have to bring this value down here and say that the normal force at point A will be equal to 13.8 plus 0.8 times 9.8. And that'll give us a force of 21.64 newtons. And that is our final answer.